3.5, complex zeros and the fundamental theorem of algebra. Okay, so first of all, the fundamental theorem of algebra, every polynomial with complex coefficients has at least one complex zero. Now, I want to make a note here that that complex numbers, let me just do a little bit review on what complex numbers are. Okay, those are the numbers a plus bi, where a and b are real numbers. Okay, so like, for example, 3 plus 2i, 7 minus I, etc. Those are examples. But one thing that I want to remind you of is that real numbers are also complex numbers. Okay, so real numbers are complex numbers because, like, if you have a real number, let's say 3, that's a real number, right? Well, it's also 3 plus 0i. So it qualifies as being a complex number. Okay, so these coefficients could be real numbers, and then but a polynomial is going to have at least one complex zero. And in fact, if you go to the second part, the complete factorization theorem, if p of x is a polynomial, then p of x can be factored into linear factors over complex numbers. So what that means is that means if you have a polynomial like this, okay, so p of x is going to be this leading coefficient times x minus c1 times x minus c2, and so on, x minus cn. Okay, oh, this should be an n right here. Okay, so essentially, such a polynomial here can be factored like this, where you're going to, and then the zeros theorem is telling you that every polynomial with degree n greater than 0 has exactly n zeros counting multiplicities. Okay, so if it's power n right here, which this one is, there's supposed to be an n, then it's going to have n zeros. So like if this is 3, then it will have 3 zeros, and we'll factor into 3 terms like this. If it's 4, it will have 4 zeros. I'll factor into 4 terms like this. Now, some of those zeros could be repeated. So like if 1 is a 0 twice, is a 0 multiplicity 2, then that counts as 2 zeros. Okay, so for example, let me get into number 1 here, for example. The polynomial, here it's in factored form. Now the degree is going to be adding up the degrees of these, adding up the multiplicities. So this is x squared, so it's the power of 2 right here, so that's 2. This is cubed, that's 3, and then that's just for the first power. So that's going to be, the degree is going to be 6 in this case. The zeros are, from here you go to 0 of 0. This is 1, and this is -9. So 0, 1, and -9. 0 has multiplicity 2, because that's raised to the second power. And 1 has multiplicity 3. And then 9 is just multiplicity 1, or it's also known as a simple 0. Okay, number 2. If a is a 0 of the polynomial a, then x minus a must be a factor of p of x. Okay, so 1, for example, here 1 is a 0. So x minus 1 is a factor. And if it's a 0 of multiplicity m, then x minus a to the m must be a factor. Okay, so for example, 1 is a 0 of multiplicity 3. So x minus a to the third power is a factor of p to the x when you factor it like this. Okay, And 0 is a 0 of multiplicity 2 here. So here m is 2. And so x minus 0, which is just x squared, is going to be a factor. Okay, so that's how that works. Okay, let's move on to a little bit more. Number 3, number 3. So a polynomial of degree n greater than 0 has exactly n zeros. Okay, so if n is the power, is the degree, then it's going to have that many zeros. Okay, and then number 4, if the polynomial function p has real coefficients, and if a plus bi is a 0 of p, then a minus bi is a 0 of p. So if 9 plus I is a 0, then 9 minus I. Okay, this is from the conjugate zeros theorem, and you need for p to have real coefficients. Okay, and I remember real numbers are complex numbers, but not necessarily the other way around. There are complex numbers that aren't real. If it has real coefficients, if the coefficients are real, that means, for example, if your polynomial is x cubed minus 3x squared plus 7x minus 2, these are all real numbers. That's 1. The coefficients are 1, -3, 7, and -2. And they're real numbers. Okay? So if you have a complex 0 of this, then its conjugate is also a 0. So they come in pairs when they're real coefficients. Now, if these are non-real coefficients, then this is not going to be the case. Okay, you could have, you probably will have complex zeros where the conjugate is not a 0. Okay, and then the second part, this other statement here, linear and quadratic factors theorem. Every polynomial with real coefficients can be factored into the product of linear and or quadratic factors with real coefficients. Okay, and then, so if it's got real coefficients, then you might not be able to factor it into linear factors, but you can factor it into product of linear and or quadratic factors. So you might have some of those quadratic can't be factored all the way down. Okay, we'll do some examples of that later. Okay, so let's look at number 5. True or false? Let p of x equals x to the 4th plus 1. Okay, here, it's to the 4th power, right? So it says, because it's degree 4, that means it's going to have 4 zeros, so that's true. 4 complex zeros. Okay, and then part B, the polynomial p can be factored into linear factors with complex coefficients. Yeah, that's true. You can factor into linear factors with complex coefficients. Now, what you can't do, what is still up in the air is whether you can factor it into linear factors with real coefficients, which you can't do with this one, because this one, if you look at part C, some of the zeros are real. That's false. It has no real zeros. Okay, because no matter what real number you put into here, when you take to the 4th power, it's going to be greater than or equal to 0. And when you add 1, it's going to be greater than or equal to 1. So it can never be, no matter what number you put in for x here, it can never be 0. Okay. Okay, so if, in other words, here, if x is real, then x to the 4th plus 1 can never be 0. Cannot be 0. It can't be 0. So that means that it has no real zeros. Okay, let's look at number 5. So here we have another polynomial. And probably you're probably thinking, oh, let's factor that. So you factor an x out, and now we can see that 0 is a real 0, is a 0. And then from here, plus or minus I, those are going to be zeros. So like if you take that and set it equal to 0, and then extracting square roots, you get plus or minus I. Okay. So the zeros are 0, I, and negative I. Okay. So part A, true or false? The polynomial P has 3 real zeros. Well, it has 1 real 0 and 2 complex non-real zeros. So that's false. Let's see. P of x is x times x squared plus 1, and x squared plus 1 has no real zeros. So this would be the best answer to that one. Okay, the part B, the polynomial P has at least 1 real 0. That's true, because 0 is real, and it's a 0. Okay, and part C, the polynomial P can be factored into linear factors with real coefficients. That one's false, because this has no real zeros. Now, if all of the zeros with this word of a polynomial are real, then it can be factored into linear coefficients with a real coefficient. It can be factored into linear factors with real coefficients if all the zeros are real. Okay, let's look at number 7. Okay, so number 7 is to find all zeros and factor P completely. Okay, so here, the easiest way to do this one is to realize this is like a quadratic. So if you think of x to the 4th as being x squared quantity squared. So like if you take x squared times x squared, that's x to the 4th, right? So you can factor it this way, just like you would a regular binomial. Now that's because it goes 4 and then it goes x to the 4th and then x squared. There's the x cubed and x terms are not there. If the x cubed or x term were there, then you wouldn't be able to do it this way. But since they're not there, we just take advantage, and then minus 7 and plus 1 is going to work. Okay. So so we set each of these equal to 0. And we have plus or minus root 7. And then here, this is just like the previous problem. We have x is plus or minus I. Okay, so the zeros are going to be root 7, negative root 7, I, and negative I. Okay, so those are going to be our zeros. That's all zeros. And make sure you have 4 of them because the degree is 4. And then you want to factor it completely. Okay, so that means what you can do is just take the coefficient here, which is just a 1, so you don't have to write it. And then take x minus each of these. So x minus root 7, x plus root 7, or x minus the negative root 7 is x plus root 7, and then x minus I, and x plus I. Okay, and that's how you would factor it completely. So that's factored into linear factors, but it's over the complex numbers, not over the reals, because these two right here are complex non-real. Okay, number 8. Find a polynomial with integer coefficients that has degree 2 and has these two zeros. So these are complex zeros. Okay, so this is the same principle. When it has zeros, you can just write down, you just take x minus the first 0. That's going to be the first factor, and then the other factor is x minus the second 0. Now, if they said that they wanted to have integer coefficients and that they just gave you they just gave you 1 0 here, then the other one would have to be a 0, because integer means real, and then real means that if one of these complex numbers is a 0, then the conjugate has to be a 0. These are conjugates of each other, so they're gonna. So when you multiply these together, the imaginary part should just completely go away. Okay, and so then that's what we get to do now. So let's choose the FOIL method. First is x times x. That's x squared. Okay, now the outside ones would be minus, you get that minus, and then x times 1 minus I root 7. And then you have the inside one, which is this times this. That's another minus x times 1 plus I root 7. And then you have the last ones, which you have a minus times a minus, so those will cancel to a plus. And you have 1 plus I root 7 times 1 minus I root 7. Okay, and so right here, when you distribute the x, you get minus x plus I root 7x, and then minus x here, and then minus I root 7x. And then here, this is going to give you 1 plus root 7 squared. Okay, so remember that, let me just refresh your memories here. When you have a plus I, okay, a plus bi times a minus bi, that is going to be a squared plus b squared. Okay, and so a is 1 and b is root 7. So that means, that's why we got a squared plus b squared right here. Okay, now if you forgot that, that's fine, because if when you multiply this out, that's what's going to happen anyways, because everything else is going to cancel. Okay, and also this term right here and that term is going to cancel. Like I said, when you do this correctly, all of your non-real terms are going to go away, and you'll just be left with real coefficients. So x squared, and then you have minus x and another x, so that's minus 2x. And then here, this is 1 plus 7, which is going to be 8. Okay, so x squared minus 2x plus 8. Great. Now let's go to the next one, number 9. Okay, so here they say, find all zeros of x cubed plus 10x squared plus 30x plus 36. Okay, what I like to do here is this one, it's not really giving you any, I mean, what you would normally do when we didn't have like so much technology is go through the list of possible rational zeros. So like, which I said was the factors of this divided by the factors of that, of this coefficient. So the factors of 36 divided by factors of 1. So that's going to be 1, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and then 9, and 12, and 18, and 36. Okay, so like just go through those until you find one of them, and then use synthetic division to break it down to a quadratic. But since we have technology and GeoGebra is allowed, then let's go ahead and use the tech. Let's take advantage of that. Okay, so I'm going to GeoGebra here. Okay, so I go here to GeoGebra. I'm just adjusting my window here. Okay, so geogebra.org, start the calculator. And I'm going to put the polynomial in. Okay, the polynomial was x cubed plus 10x squared plus 30x plus 36. Okay, so I'll put that in there, hit enter. Okay, so I put that in, enter. And this actually, the graph only crosses the x-axis one place, right here. Okay, so that's telling us that -6 is a 0. So that's really useful information. That's going to save us quite a bit of time. So we know, so from the graph, we see that it went through -6. So let's, so what you're going to do is we'll use that -6. It didn't go through the x-axis anywhere else. Okay, that doesn't mean it doesn't have any more zeros. It does mean that the other two zeros are non-real, that they're complex non-real zeros. Okay, so we'll put in, let's see, 1, 10, 30, and 36. Okay. So bring the 1 down, multiply, that's -6. Add, that's 4. Multiply, that's -24. Add, that's 6. Multiply, that's -36. Okay, so great, that's 0. That means that we've confirmed that -6 actually is a 0. Okay. And then what's important is this right here, because now that is x squared plus 4x plus 6. Okay, we want to solve that. Now the question is solving that. And use the quadratic formula. Okay, and then for that one, A is 1, B is 4, and C is 6. Okay, so -b, or -4, plus or minus the square root of b squared, which is 4 squared, minus 4 times A times C, all over 2A. So that's -4, plus or minus the square root of 16 minus 24, all over 2. -4 plus or minus the square root of -8. Okay, so the square root of 8 is 2 root 2. And then the square root of -1 is I. So put that there. Now now you can factor 2 out of the numerator. And then those will cancel. Okay. So your zeros are going to be -6, and then -2 plus, wait a minute. Yeah, plus root 2, I, and -2 minus root 2, I. Okay, so those are going to be our 3 zeros. Okay. Part number 10, find all zeros of this polynomial. Now, life will be a little bit easier if we just factor 4 out, because every single term here is divisible by 4. So you can just factor 4 out. And that's not going to affect the zeros. Okay, so if we factor 4 out, then this this part right here will have the same zeros as the original. Okay, so again, what I'm going to do is I'm going to use Geogebra again, and I'm going to put in 4x to the 4th plus 4x cubed plus 5x squared plus 4x plus 1. Okay, so we're going to go ahead and put that into Geogebra. So we just like erase that. Okay, so it's 4x to the 4th plus 4x to the 3rd plus 5x squared plus 4x plus 1. Okay, so now here we go over and look at the graph and look at that right there. Okay, so this is telling you it intersects at negative, well, it says negative 0.5 and then a bunch of zeros. Okay, that's, when that happens, what typically the case is it's doing some round off error. So negative 1/2 is what this is probably is. This is probably negative 1/2. And also notice that it's like a parabola here. So it comes down to the x-axis, touches, and then goes back up like this is like the vertex of a parabola. If you just look at this part right here. Of course, if you go further into it, then whoa, it looks, maybe it still looks like a parabola. That's interesting. Okay, so anyways, negative 1/2, because it's like a parabola, then this is actually probably a 0 of multiplicity 2. So that means 1/2 is like counts as 2 zeros of the function. Okay, so let's remember that one, negative 1/2. Okay, so we'll go back to the problem and negative 1/2. We'll run synthetic division on that. Okay, so this is 4, 4, 5, 4, 1. Okay, so bring the 4 down. Multiply, that's negative 2. Add, that's 2. Multiply, that's negative 1. Add, that's 4. Negative 1/2 times 4 is negative 2. Adding, that's negative, that's 4 minus 2 is positive 2. And then negative 1/2 times 2 is negative 1. Okay, and so that's good, that's 0. That adds to 0. Now, I said that it was a double 0, so we're going to do it again. Negative 1/2 again, a second time. So bringing the 4 down. Multiply, that's negative 2. Adding those gives you a 0, so that's great. And then multiplying there gives you a 0. And adding here, you get a 4. Multiplying these together, negative 1/2 times 4, that's negative 2. So that's great. It is a double 0. It is a double 0. So now, to find the remaining 0, or the remaining 2 zeros, we use this piece right here. Okay, and that's 4x squared plus 4. And here we can factor a 4 out. So we're just looking at this part right here. And we've done this before. This is plus or minus I. Okay, so the zeros are going to be negative 1/2 appears twice. So then you have to put 2 of those in the answer, and then I and negative I, like that. Okay, number 11. Okay, so here you have x cubed minus 2x minus 4. And again, we could take factors of 4 divided by factors of 1. So it'd be plus or minus 1, plus or minus 2, plus or minus 4. Check those until we find one, and then you synthetic, and then go from there with the synthetic division results. Okay, but let's go ahead and put this into GeoGebra because it's easier. So x cubed minus 2x minus 4. We'll put that into GeoGebra. Just got to erase the previous one. So x cubed minus 2x minus 4. Okay, so hit enter, and there we go. Okay, so now we can see here that the graph is going through 2. So 2 is a 0. And it looks like that's the only real 0 because it's the only place where it intersects the x-axis. Okay, so 2. Let's go back to the problem, and based on the information that we just got, it looks like 2 is very likely a 0. So we've got to put this in. Now this is missing the x squared term, so you got to put a 0. Okay, so it's missing the x squared term, so there's got to be a 0 there, and then -2 and -4. Okay, so bring the 1 down, multiply, that's 2. Adding those together gives you 2. 2 times 2 is 4. Okay, -2 plus 4 is actually +2. 2 times 2 is +4, and then those -4 and 4 add up to 0. So that's great. Okay, so 2 is a 0. Now we just need to figure out the other ones. And this gives you x squared plus 2x plus 2. Now, from the graph, it did not appear that it intersected, well, it didn't intersect the x-axis anywhere except this 2 right here. And the problem states to factor p into linear and irreducible quadratic factors. From the graph, we could tell that this is the only real 0. So, if you want, so this is what this means. If it's real coefficients, then we just factor it into, then this is going to factor into x minus 2. That's from the 2 being a 0, the multiplicity 1, so it's just that. And then this piece right here. What? Okay. So x minus 2 times x squared plus 2x plus 2. Okay, that's factoring it into a combination of linear and irreducible quadratic factors with real coefficients. So this piece right here is called irreducible quadratic. Okay, and this term here is a linear. And they all have real coefficients. So this is 1 is real, -2 is real, 1 is real, 2 is real, and the 2 is here's real as well. Okay, that's what it means by real coefficients. Okay, part B says to factor it completely into linear factors with complex coefficients. Okay, so we want complex coefficients, but we want linear. The emphasis here is linear factors actually. Okay, because the answer, it can still write down part of the answer. The answer will include this x minus 2 because it's a linear factor. And 1 is complex and -2 is also complex. They're also real, but they're also but any real number is also complex. Okay, but what we need to do is we need to take this piece right here and let's use the quadratic formula. So A is 1, B is 2, and C is also 2. Okay, so that gives us -b plus or minus the square root of b squared, which is 2 squared, minus 4 times A times C, all over 2A. A is 1. Okay, so that's -2 plus or minus, okay, so this is going to be 4 minus 8. So I'll go ahead and work that out. So 4 minus 8, that's -4, right? So -2 plus or minus 2i. Okay, the square root of 4 is 2, and then the square root of -1 is I, all over 2. And then you can factor 2 out of the numerators. And that cancels with that too. So -1. Okay, so the zeros are -1 plus I and -1 minus I. But then also 2 is also a 0. Okay, so x minus, so when you write down the polynomial, okay, you like take in consideration first that this coefficient is what did I just do? Oh man, I messed up my, no. Okay, I don't know what's going on here. Oh well. I kind of messed everything up. No, this is really bad. Okay, so what's going on? Oh, it's still right. Okay, so let's see here. Where was we? Where were we? Okay, so I wanted to point out that the coefficient here is 1. The leading coefficient is 1. That means I don't really need to put anything here. Just leave that open, because that's left open too. It's like if there was like a 3 here, I would put a 3 there. Or if it's -4 here, I put a -4 there. Okay, whatever's leading coefficient, I put there in the beginning. Okay. And then so that's the first term. That's the same thing, the same concept with this one. Okay, and then the first one would be x minus this one. So that's actually x plus 1 minus I. And then x minus this one, that's going to be plus 1 plus I. Okay, and then those would be, and that would be the answer. Okay. So the idea is, dang, I need a red. Is that a good red? So the idea is that this one goes there, and then this one goes here, like that.